Hi, welcome to Cal2, and today we're going over hyperbolic functions. So, what is a hyperbolic function? Well, a hyperbolic function is nothing more than an exponential function, as you can see here, disguised as a trig function. So this sine hyperbolic, or hyperbolic sine, is just written with a little h, is just e to the x minus e to the minus x over 2. And hyperbolic cosine, which is cosine written with a little h, is e to the x plus e to the minus x over 2. And the interesting part is when you take the derivative of a 1, you'll get the other one. So let's take hyperbolic sine e to the x minus e to the minus x over 2. And it can also be written with this 1/2 brought over of e to the x minus e to the minus x. So we all know that the derivative of a constant is just a constant. The derivative of e to the x is e. It's exponential multiplied by its exponential's derivative, and that's chain rule. So you multiply these two together, you'll just get e to the x. But when you do e to the minus x, it'll be e minus x multiplied by its derivative, you'll get -1. And as we know, a constant, multiply these together, you'll get e to the x minus, because it's multiplied by this -1, it'll turn into a plus e to the minus x. So as you can see here, the derivative of hyperbolic sine is equal to hyperbolic cosine. Now there are other hyperbolic functions you got to be aware of, and they behave just like trig functions. So tangent in normal trigonometry is equal to sine of x over cosine of x. And hyperbolic tangent, which is just tangent written with the h, is the same thing. It's hyperbolic sine, which is e to the minus e to the x minus e to the minus x over e to the x plus e to the minus x. And you guessed it, secant, cosecant, and cotangent behave the same way. So the thing you really need to know is their derivatives. So the derivative of, right here, the derivative of sine of x is equal to hyperbolic sine. And that's basically all you need to know. Now they all behave that way. So you guessed it, that the derivative of hyperbolic tangent, so the derivative of hyperbolic tangent is equal to hyperbolic secant squared. And this is really good for us because you don't have to memorize any more derivatives or integrals. The only part that gets tricky is when you take the derivative of hyperbolic secant. Hyperbolic secant is equal to negative hyperbolic secant x times tangent hyperbolic of x. Now this is different from the regular because the derivative of just regular secant is equal to just secant times tangent, but the derivative of hyperbolic secant is equal to negative secant times tangent. And that's not too big of a worry. My Cal2 teacher said that you can just think of, instead of where the derivative of cosine, where normally it would be negative sine, instead is over here. That's just another way to think about it. I just remember it just like that. So I'm just going to write the rest of them, the rest of the hyperbolic functions and the derivatives, and that's basically all you'll need to know. And in a later video, I'll do actual problems where you work it out, and we'll go over integrals, derivatives of those, and the typical problems you'll see with your Cal2 teacher